Hello everyone, Chibuisi Okorieimoh is my name. I will be presenting a paper titled Comparison of Predicted and Measured Annual Performance of a Rooftop Grid-Connected PV System in the Irish Climate. In today's presentation, I'm going to look at the methodology. Under the methodology, I'm going to look at site location and climate description, system monitoring, and method of data acquisition and assessment. Under the results, I'm going to look at system simulations, cable sizing, performance comparison of measured and simulated results, inverter percentage conversion loss, conclusions, and then future work. This study is being carried out using one of the ESB's PV plants located at Upper Drummer Road, Warren Point in Northern Ireland, within a latitude of 54.1 degrees north and longitude of 6.26 degrees west, as you can see on the Google satellite map here. The total PV plant area is estimated at about 268.8 square meters. Looking at the climatic description of this site, so as we can see in figure 2 shows monthly average temperature and relative humidity in ESB Warren Point system sites. So in this site location, we notice that the site is in a cool humid area with average daily air temperatures ranging from 4.6 degrees Celsius in January to 14.5 degrees Celsius in July, and this also is within the relative humidity of 87.6% in January to 82.4% in July, as we can see in figure 2. So in figure 3 is actually showing a daily solar irradiation, the rainfall, and the wind speed in ESB Warren Point system site. As we can see that from the graph in 3A, the daily solar irradiation on horizontal surface in Warren Point ranges from 0.44 kilowatts hour per meter squared in December to 4.23 kilowatts hour per meter squared in May. Monthly rainfall in the year fall from a low of 67.76 millimeter in February to a high of 106.95 millimeter in October. Wind speeds are generally high, as we can see in figure 3B, and it ranges from the average of 3.8 meter per second to 5.7 meter per second at this location. In order to measure the system performance, the data used in carrying out this study were acquired using data acquisition system, and this data acquisition system consists of 2 sensor boxes and a data logger. The sensor boxes measure the total in-plane solar radiation on the PV modules. The sensor boxes connected to the data logger were recorded at quarter-hourly intervals. The quarter-hourly interval data is used because of its uniformity with other data used in analysis of energy output, percentage of energy yield, performance ratio of the system, and efficiency of the system. Table 4 here shows the PV system simulation of a rooftop grid connected system. The inter-row spacing, as you can see on the diagram, is to prevent shedding effects. So when the sunlight falls incidentally on the surface of the PV module, then it generates direct current. The direct current now passes through the inverter. Then the inverter now converts the DC to AC. Then the AC current now passes through the transformer. Then from the transformer to the net meter, and then to the grid, where the electricity is being generated for consumption. In cable sizing, the relative power loss at DC is 0.16%, while at low voltage is 1.15%, while the medium voltage recorded no loss. In table 3, we have the PV system and inverter performance. So in this PV system inverter performance, we have the PV modules which generates power, the maximum power point tracker which ensures maximum DC power outputs, the grid connected inverter which converts DC output to AC power, which will later be fed into the grid. In the performance comparison of system measurement and system simulation, we have almost the same results. For instance, in system performance ratio of a system measurement, we have 85.17%, and that of system simulation gave us 85%, and the efficiency of system measurement is 15.82, and that of system simulation is 15.8. So this shows that the result of the prediction and the result of the system measurements are almost the same, as we can see in table 4 and 5. The comparison of measured and simulated performances of ESB wiring points of rooftop grid-connected system are being summarized here using a graph. So from the graph, we can see the simulated bars are the blue bars, and the measured bars are the orange bars, and you will see that the results or the result of the simulation and the measurements are almost the same. Table 6 shows the summary of the comparison between the system simulation and the system measurements. And we can see that the result of system simulation and system measurements are almost the same. So which means that the prediction or simulation of a site location is very necessary before the installation is being made. So table 7 here shows the inverter conversion loss. So in this case, the DC energy cannot be equal to the AC energy because of energy loss during the conversion process, either from the cable, from the inverter, or from the solar panel. So as we can see that the average inverter efficiency, we have about 99.4, and the average inverter percentage conversion loss is about 0.62. So in conclusion, now say that external environmental factors such as humidity, dust accumulation, wind velocity, shading, ambient temperature, and operating cell temperature negatively influenced PV output performance. So because of this, it's necessary to inspect the proposed geographical location before the installation of PV systems. And this is done through a prediction or running a simulation study using the geographical location coordinates such as the longitude and latitude, the azimuthal angle, the PV parameters stated on the data sheets. So the future work for this study will be carried out on comparative study of predicted, simulated, and measured annual performance of a rooftop grid connected PV systems of 3 different site locations. The idea of doing that is to check the influence of shade, dust accumulation, ambient temperature, and wind velocity on output performance and output performance, the efficiency of PV systems. So it is very important that simulation prediction is being run in a particular location before the installation of a PV system. So this will help to increase the output performance of the PV system. Okay, so in my study, I've compared the simulation system simulation results with the system measurements, and I've seen that the result of the system simulation done by prediction is almost the same with that of measurement. So it's not necessary that system prediction or system simulation is being considered first before installation is being made in a particular location. So having said all that, I wish to thank you for your time. I wish to thank you for listening to my presentation, and I will be happy to entertain any question. Thank you.